Welcome to Fast Talk, the Velo News podcast and everything you need to know to ride like a pro.
Hello and welcome to another episode of Fast Talk. I'm Chris Case, managing editor of Velo News, joined as always by my distinguished co-host, Coach Trevor Connor. Data. Not long ago, people looked at you funny if you had a 2-inch screen mounted to your handlebars. Now, we ride with head units the size of cell phones, sensors connected to our limbs, and wearables that track every step and heartbeat, and no one bats an eyelash. A few episodes ago, we talked with Hunter Allen about the history of power and how we got to this point. Today, we're asking this question. Where is all this data going, and what do we gain by covering our bodies in sensors like something out of a Star Trek Borg episode? And yes, Trevor made me use that reference. I have no idea what it means. In this episode, we'll talk about, first, the data revolution. There's been exponential growth in the amount of information we're now able to collect and analyze. That data is allowing us to look at our training in ways we never could before, but it also comes with some dangers. Next, we'll discuss the rise of artificial intelligence and machine learning in training software. That's a fancy way of saying that the software no longer just tells you how far you rode and what your average power was. Increasingly, it is telling you what your rides mean, where your form is at, and gives clues to what you should be doing. Then we'll address the 3 stages toward machine learning. First, there is the descriptive, how far you rode, how many hours you've trained this month, and so forth. The second, where we're at now, is predictive. Software crunches your data to predict what's going to happen to your form. Finally, in a few years, we hope to move into the prescriptive stage, where the software starts telling us what we should do. Finally, since these changes are going to have a significant impact on both athletes and coaches, we'll address what they each can expect. Should coaches start refreshing their resumes, perhaps? Our guest is the lead engineer for TrainingPeaks and their coach-focused software package WKO 4, Tim Cusick. He's been coaching for 18 years, including some incredible athletes like Amber Neben, who is a multiple-time national and world champion. He comes from the world of data analytics, which gives him a unique perspective on training science. He's actually been working in artificial intelligence and machine learning since the 1990s. We'll also hear from Armando Mastracci, the developer of Exert training software that grew out of Armando's own experiences as an engineer and crunching large amounts of data to find trends. Dean Golich, a head coach at Carmichael Training Systems, will share his thoughts on where the software is headed. And finally, we'll touch base with Joe Dombrowski of the Education First DrePack World Tour team to get his take on how pros are reacting to the data revolution. With that, let's make you fast and hopefully live long and prosper. So maybe we'll start at the data revolution, Tim, and maybe you could tell us about the breadth and depth and just the immense quantity of data that people have at their fingertips these days compared to even a decade ago or 2 decades ago.
You have to start at kind of the point we're at today when you start talking about data, right? The point we're at today is you have a modern athlete, I like to call it. What's different with a modern athlete than with the athletes of the past is that modern athlete is now a data gathering machine. I mean, if you look at the explosion in the last really 5 to 10 years in wearables, data gathering devices, analysis programs, it really is this idea that there's a data revolution going on. The challenge of the data revolution that I've seen in the years that I've been involved in it, and I've had the luxury of looking at it as a coach, as an endurance coach, is first we start with the data. So we didn't start with a solution or a hypothesis. Devices actually matured before we know or knew what to do with the data. So the revolution really has been an athlete and a device-driven revolution. We have a massive pool of data. That revolution now is evolving into maybe phase 2 of the revolution. And that phase 2 is, what are we going to do with that data now that we have it and we've begun to learn with it, and we're putting it into some a really cognitive approach towards improving training, reducing injuries, improving single athlete performance, improving team athlete performance. But that's the cutting edge of the revolution. So it went from data device to more and more athletes gathering data. And only now are you at the beginning where people are saying, what can we really, really do with all of this data?
Yeah. Given that we have all of this data to work with now, and not everybody has all the tools necessary to deal with it and to interpret it and to manage it, what are some of the weaknesses of the data revolution?
So when you look at the weaknesses of the data revolution as a whole, the problem is people who don't know how to utilize all of the available data. And I shouldn't say people, maybe it is, individuals or companies or whatever it is. You can really create what I call the data haze, meaning if you selectively bang away at a big bunch of data looking for a solution, eventually you can actually find that solution. If you change the database, do segmentation, don't keep data integrity, you can validate that. And I think we're already seeing that to some degree. I think everybody should look at each one of these systems with a grain of salt. This is a very new field for sports as a whole and for endurance sports. I think what you need to be leery of is that people are accurately using the data. Because if they're not accurately using the data, you're kind of creating a fad versus physiology. I've seen systems validating things. I refer to it like a fad diet. If I just stop eating this, I'll lose 40 pounds. The reality is data gives more, and the amounts of data we have now do give more opportunity for misinterpretation of and misutilization of that data.
So I was going to refer to the way I think of this is cherry picking. And it sounds like that's what you're talking about, is when you have a lot of data, people are going to be able to pick the information they want to show them what they want to see. So the classic example that I keep having to correct people on is somebody wants to figure out their FTP, and their real FTP might be 250 watts, but they don't like that. They want it to be 280. So they find the data that confirms what they want to see.
I couldn't agree more. I'll tell you that in the time for me since we launched the power duration model in WKO4 to sitting here today, I've probably had that argument more than 1,000 times. And it's just true. And part of why we did the power duration curve and what we've done in our side of analytics and thinking was we wanted to give somebody a well-modeled, a accurate process to at least sit back and compare. And if you see big differences in what the data is telling you, of course, we leave that to the individual to interpret why. And maybe the why is you just want it to be a big number, or maybe the why you have a difference because you don't understand something. But the power duration curve is an excellent example of how to use data to give you a tool to make sure you're not introducing bias or cherry picking or using those small things to be as truth, or you're validating everything as truth without some background.
Could you give an example of a bias in this instance?
All right, but I'll give you the honest answer. When we developed the power duration curve, I'm obviously talking about something in WKO4 and our modeled science. There's other models out there that do what we do, and I encourage people to look at different models. They do slightly different things, understand what each one does. And modeling has gone back really since the Bannister model. We're not talking about something new, but I think we're talking about something that's pretty accurate. Obviously, I have that bias, but I do believe it. Now, for example, is one of the things the power duration model has forced people to do is to relook at threshold, at FTP, exactly the example we were just talking about.
Yep.
When we launched it, we literally got hate mail. Like, my FTP is 20 watts higher than your stupid model says. And it would be like, okay, so now walk me through your data. What's been your peak 20 minute, 40 minute, 60 minute, and what's maybe your 60 minute normalized power? Let's look at different things that might give us insight. And time again, and I mean literally more than 95% of the time, the data, the individual performance data really wasn't even there to support what that individual believed their FTP was. So here's where you have a data tool, right? Something based on big data that gives insight into physiological performance. That is a very good tool that you could sort of vet your opinion, how fit you think you are versus how fit the data says you are. Mm-hmm. The purpose of this type of data usage is it gives you at least something to look at to give you a good mathematical relationship of the performing human physiology, what's happening inside of me based on the data that I'm producing. Right. And then it makes you at least think and question. And if you question and say, no, I'm right, that's fine. And if you say you question yourself and say, no, this model is right. Actually, I would say that's probably better yet, to be honest with you, based on the number of mistakes I've seen people make. But that's a choice you make.
One of those other training software packages is Exert, a newcomer in the field developed by Armando Mastracci. And Armando, I apologize, my Italian is horrible. Armando is a software engineer and a recreational cyclist who was fascinated by the data and decided to start looking for the trends, eventually developing a robust package. He shares his thoughts of what this revolution means and what he thinks riders such as himself are looking for.
What I think is amazing in terms of what's happening today is that we're seeing a greater proliferation of athletes now with training with power. With the price of power meters starting to decline, as well as the interest in winter cycling. So we're seeing a growth of individuals now using trainers indoors, as well as these virtual environments like Zwift, which are becoming extremely popular. And all of these are based upon power. So all of these market forces are really bringing a lot more individuals into the market in terms of wanting to train with power. And what's different about these is that they're not necessarily really competitive athletes. They're not necessarily professional or looking to be the top racers in the country. A lot of these are very much recreational cyclists, right? So they want to use power just to stay fit, right? They want to use power to kind of track their progress. That's different, right? When you're looking at what software needs to do, right? So software has always been characterized by, and how do we use the tools so that we can better analyze all the data for these top athletes? So they're usually in the hands of either sports scientists or really the enthusiasts who are really into examining the data. Those were the original kind of targets for the use of power data and for interpreting it. But now that it's started the greater proliferation of power data and power meters, we've got to start to look at how do we provide information about their own fitness and their own progress within the software without having to dive into all of the analytics per se that are currently available. So this is kind of what we focus on within our software is how do we make the application and understanding of the power data something that's more accessible to a broader range of people. So as an example, individuals who, they're not going to do FDP tests on a regular basis, right, yet they still want to track their progress. Right. So we provided a tool that allows them to kind of track how well they're improving and how well they're progressing. So this is really, really important, I think, for the greater population. So just in the same way we say, okay, you never have to do an FTP test, right? We talk about, we just grab your threshold power, your other fitness variables from your data. We grab that automatically. And it doesn't need to be a test. It might just be a ride you just rode on Zwift where you just hammered it out. Or it could be a group ride, right? All these are what we say, express your fitness. And they happen with greater frequency. And these expressions of fitness are really markers. It's kind of like, imagine, doing an FTP test 2 or 3 times a week. One of the other key things that I'd like to add, though, is that, and Ned kind of talked a little bit about this in your last podcast, which was kind of cool, which was that training's got to be fun, right? And a lot of people who are looking to train, they don't necessarily want to follow the rigorous program that would be provided by, let's say, a very static training plan or from a coach per se, who's going to be very specific about the training that's going to be prescribed and how it's got to be followed. So they really want to see how they can use the power data to give them sort of a visual and understanding of how well they're training and what kind of training they can do to improve without the structure necessarily that you would see within a professional athlete, for example. These athletes have other lives, they work, they travel. They've got to have a system in place that's going to accommodate their kind of variability that they have in their life. And so I think that's another aspect that we're going to have to start to see in software is something that's going to be more accessible to a broader range of people, something that's a little more adaptive, yet still provide direction and guidance and improvements and the visualization of those improvements.
While both Exert and TrainingPeaks have been able to take advantage of this explosion in training data, there are challenges. Let's get back to our conversation with Tim about what these challenges are. So you had a couple caveats, and I definitely wanted to talk to you about these. Yeah. One was that you need a lot of data. That's part one. The other one that I always have a concern about is it based on your best numbers or what you might call your more actual or day-to-day numbers? So sorry, I'm not explaining this well, but to give an example, you always have that danger of an athlete just cherry-picking a couple key workouts where they're putting out great numbers, plugging that into the software, and they get a power duration curve that's just not realistic for them. And then if you're getting recommendations based off of a not realistic curve, they could also get into trouble. So how do you avoid that? And I'm sure part of the answer to that is you need a lot of data, right?
Well, yeah. So let's define a lot. So to get at a minimal, you need 90 days worth of performing data. Now, to look at some of the historical and go beyond that, obviously you'd want more than 90, but you can begin to do a lot of the optimization and individualization with 90 days. Obviously, if you had years worth of data, you can go and take the insights further. But the data itself is very important. So what you need in your data is, one, you need accurate data. One of the things that we've really focused on is the ability to look at the actual recorded data and make sure that, that data is accurate. In the power duration curve is what we call, it's a smart curve, meaning if it runs its own checks, and you can actually, there's a report that shows you the plus minus, the error, the sum of errors in your power duration curve. We want people to validate their own information if they're not sure. But we're looking at that at all the times. If we see an error that creates more than a 5% swing, it won't even calculate. So you have to have good data to make it work. If you have bad data, like spiky data, or your power meter's really wacky or whatever, it won't work. So first thing is you need good data. Second thing is the power duration curve is based off all data, but it's driven by maximal data. You don't need a lot of it, and it's unique. Just, the model itself is part of learning, right? It's part of the machine learning. It's ongoing. It's learning. You need a maximal effort at short, medium, and long. And that definition of short, medium, long can slightly change by your actual performance. It's something we call unstructured testing. We do recommend that athletes using the power duration model to track their physiological changes. You need to, once every 4 to 6 weeks, just like you would do in any kind of power-based training program, you need to do 3 tests, a short, a medium, and a long. And there's a way to identify, the model itself tells you where to test. You have to read it. Someday I need to automate that. That'll go on the list. But you can easily see the short, medium, long place, and then you test that. And if you just keep doing those 3 tests once every 4 to 6 weeks at maximal effort, then the model will be pretty darn accurate.
So what are typical lengths for the short, medium, and long? It sounds like it's personalized, but
typically you see something, it'll be between 10 and 45 seconds. It'll be between 2 and 8 minutes. And then it'll be out somewhere between 14 and might be all the way out as far as 40 minutes. So it really depends what you've been doing and what you're focusing on in your training and stuff like that.
Okay.
So it's usually in that range. 3 days before, right, you drill it at a town line sign and you've gotten a really good maximal 5 second. The model already sees that. So there isn't a need to replicate that. It's looking for normalized residuals is what it utilizes as the mathematical term. So it's looking for variations off the model, and it's picking the negative variations and saying test in this area.
Now, is there any danger? Let's say you did a race a week ago, you were peaked for it, you had just an absolutely banner performance, and you put out some of the best numbers you've ever seen. Is there a danger of that giving you a curve that's actually above your typical day-to-day level?
Wow. You're probably going to have most of your listeners put on their flame retardant suit right now. Okay. But I'll answer that.
I want to hear this answer now.
The certain models, I'm not even going to use model names because people argue about this too much, and it's an over precision in my book. But you need to know the difference to understand what we did, at least, and what I believe is the best answer. Certain models utilize maximal data. So the curve, if you can visualize it, skims across the top of maximal data to predict other maximal data.
Okay.
That's not what we did. So I have to say that to say back to you, if you have that breakthrough moment where you have that kind of performance, the model will adjust to it, but in a way that you should be able to replicate. Our model is based not on that one-off. That's why if you look at it visually, if you look at a mean maximal power line against the power duration curve, the curve doesn't bounce across the top, the ultimate uppermost points, because we don't want to make a model that predicts some maximal performance you might have. We want a model that's reflective of the underlying physiology. And you'd actually, when you look at our model, the curve goes through your mean maximal power line because we want it to be something that drives the training insight, the training application, so that you're doing things that are replicatable, not just a one-off. The only caveat there is if, let's say you forgot to calibrate your power meter and you just happen to be running 20 watts high. Yeah, you're never going to buff that out, right? That's going to happen occasionally and you're never be able. But if it's an honest data number, no, it'll make adjustments because remember, it's going to tweak the underlying physiology, not repredict the power number.
Which brings us to a really simple but really important point for all listeners, which is if you are analyzing this data and you want to use these tools, you have to be careful about every time you go out for a ride, calibrate your power meter. And when you see a ride where you go, that's not real numbers. Like I'm riding with my mouth closed and it's saying 450 watts, not uploading that file. Because if you put it in enough bad files, I don't care whose tool you're using, it's going to give you bad data.
Agreed.
I had this interesting conversation with a guy 2 years ago who was training at a studio that I work at, and he had his FTP way too high. And he was upset about these intervals because they were 5-minute intervals and he couldn't complete one. And he's like, well, I don't get it because my FTP is X, but I just, something's up here. And I go, well, I don't think that's your FTP. Oh, yes, it is. I've tested it. I went, well, what do you define FTP as? He goes, well, it's power you can hold for an hour. I'm like, can you do a 5-minute interval at that power? No. Then it's not your FTP. Yes, it is. And I finally said, where did you get this from? Well, he had done an FTP test 2 years earlier, hit absolutely peak numbers, and was saying, that's my FTP for life. And had to kindly say, it's December. You did that in July on a really good year. You might want to adjust this. And it's that he didn't want to face where he was at. He wanted to see the best he's ever done.
That is a bit strange to me in a general sense. Not the story makes total sense. I think what's strange to me is people's desire to hold on to these things as long as they do. If your end goal is to improve, and you know that to improve you have to train in certain zones and do certain things at certain times, but your numbers are all off, then you should be aware that you're going to be training incorrectly at all times almost.
So, Chris, and that is so right. What you're both saying is so correct. People ask me all the time because I have such a wide exposure in professional teams and riders and groups. I get this question or a similar question all the time. And they want to know kind of what's the biggest observation of the mistakes with data I see. And if I was to just move away from all the fancy talk about big data and modeling and all that other stuff, here's the answer, right? Most people, and I bet you that number's 60%, and maybe it was more 2 years ago and a little less now, have their threshold set too high. That means their training zones are too difficult to achieve, which result in two problems. One, they can't deal with the fatigue resulting from that, so they're too tired to adapt. It's too much work. Or two, and the one that I see most prominently that people don't let up on, is that they have a high number of failed workouts. Exactly like Trevor's example. Wow, this athlete's got they're trying to do this 5-minute interval at a power rate that's too high. They fail. They can't complete one interval, or they can't complete the set of intervals. And then they cool down and go home and just say, it wasn't a good day for me. I just wasn't feeling it. And then they come back tomorrow and they repeat the same behavior. But they can't be honest with themselves at times and say, you know what? Maybe my threshold is set too high. Maybe I'm working too hard. The message there is that's probably that performing athlete's number one barrier to improvement.
Right.
And to go forward, they need to go back. And if they don't mentally let go of that point, they're not going to go forward.
And to throw a third issue in there, when you're talking about FTP, which is this estimate of your maximal lactate steady state, that's a true physiological break point in our bodies, where when you get above that intensity, certain systems in our, certain pathways in our bodies kind of shut down, others pick up. I don't want to go too deep into that, but basically think of it as when you're training over that MLSS point, you're really relying a lot on anaerobic metabolism, where when you're training at or below, you're much more working your aerobic pathways. So if you have your FTP set too high, what you're going to end up doing is really, really hitting your anaerobic pathways, developing those. And I see this all the time. They become these anaerobic animals, but they can't race very well because cycling is still an aerobic sport.
I think that's an excellent observation. And I think what you said there that's important for people to recognize, one of the costs, right? So one of the things I preach in all coaching and training, everything's got a cost benefit. And one of the costs of having your FTP too high is you are doing more work anaerobically. And what's so important you said is I call it there's an action and a reaction, right? There's a response to all training, and some of that is sympathetic and some is parasympathetic.
Good point.
If you're doing that anaerobic work and you're doing it, you think you're working because pain is gain, right? But it comes down to the energy system that you're training. You're developing it to perform a specific function, racing, event, time trial, whatever your floats your boat. But you're training that energy system to support your desire to improve. So the cost sometimes of doing that, it might only seem like your threshold set 10 or 15 watts too high, but that might have a significant change, exactly as your example is giving, on the response to the training that you're giving. And I think people, in the name of having that number be a little higher, frequently make that mistake.
That's a great place to start delving into the 3 phases of analytics. Maybe we could start with some definitions that people may not be familiar with. I know we've already tossed out the term machine learning a couple times, but maybe you could give a couple definitions to set the stage.
So when you start talking about machine learning and artificial intelligence, right, we always put those two together, and people think that they're the same thing. They're two separate things. So artificial intelligence, really, to be more technical, it's a branch of computer science dealing with simulation of intelligent behavior in computers. That's the technical definition, right? I'm reading that off a sheet. What that means is you're taking a program and you're putting a whole bunch of data and programming and information in there, and you're hoping it makes decisions like a human and acts. So that's when you start talking about artificial and AI, that's what it is. Machine learning is a further extension of AI where you design a program that learns, in this case, let's call it learns like a human, or maybe better, but learns like a human would learn, where you design the program to learn and then you plug it into a bunch of data and it learns. And those are two different things, but you're on the cusp of that revolution. The AI revolution is, it's part of the data revolution. That's today's mode. Tomorrow's mode is evolving that into machine learning. And that's happening now. The AI extending into machine learning and endurance athletics and in all athletics is happening more and more and more.
So basically, we just talked about this revolution in data, that we have this huge amount of data now. So really what we're talking about is creating the tools that can take this data and give you some real insights. And before this podcast, you said there was essentially 3 phases or 3 stages in this process. So did you want to take us through these stages? The first one you were saying was descriptive.
Yeah. So what you have, and these are the 3 stages that lead up to AI, machine learning. So here's how you get there. The first phase is descriptive analytics. Basically is you're compiling and summarizing reports, and then a person looks at those and they're looking for insights. And really, we've been doing this for a while. I could go back 25 years when I was writing a training diary and a bunch of notes, and I'd write down how many miles I had ridden and how fast maybe I had ridden. And then I'd look for trends, right? I'd compile, I rode 250 miles this week. I rode 1,000 miles this month. And if I keep riding 1,000 miles, look, my speed goes up.
Right.
That's a descriptive analytic. It can go all the way back to that, or any online program that just tracks and compiles data does a really good job of that. The step that you're seeing really being introduced to sports now is predictive analytics. Now, predictive analytics is where the computer does the work of looking at all that data, looking at all the trends in the underlying data. It's using models and math and statistics and some programming and other things in there to make predictions. And really what it is, if athlete X does this, they're going to get that. And that could be as simple as, oh, the prediction is if this athlete does more work at FTP, their FTP will go up. Right? That seems very simplistic in general, but it gets a lot more complex than that. But that is what a predictive analytic is. It's simply saying if the athlete does this, they're going to get that. Why is that important today? And you're seeing this being utilized more and more is if I'm a performing athlete and I've just finished a good little microcycle of training, right? And I've just been 3-4 weeks of really throwing it down and putting in my work. All I know while I'm doing the work is I should be getting fitter. Now, predictive analytics can look at that same cycle and say, oh, in X amount of time, you should be this much faster. You should be this much stronger. And you should be specifically this type of stronger and faster. So predictive analytics are what's hot right now. And you're seeing this in a lot of different programs, not just what we do. Other people are out there doing it.
Dean Golich, a head coach at Carmichael Training Systems, was part of the original group along with Hunter Allen, Dr. Andy Coggan, and Alan Lim, who revolutionized training with power back in the early 2000s. He had some interesting thoughts on where we're at with predictive software and the importance of the power meter tools themselves. You'll also notice that he throws a lot of terms around like FRC and CTL. As this training software revolution continues, these terms will likely become commonplace the way FTP and normalized power have become. For now, the one you'll need to know for this interview is CTL, or chronic training load. It's part of the performance management chart we've been talking about. CTL is often referred to simply as fitness because it's an estimate of your overall performance level.
In the teeter-totter example of accurate power meters that are sold for a good cost, and then the software is probably a little bit more advanced right now for the actual power meters. And we're in the midst of predictive versus post analytics. So right now, the post, analyzing what you have done, is probably pretty accurate. And the change in that over, say, the last 5 years is here's what a group does, and now you can individualize it with your own software to know what you actually do. So post analysis. But what we're going to see next is probably a little bit more predictive. And with that software taking already scientific principles, so whether you would Coggan's version of the FRC or say, I guess, Skiba's version of wattage prime, those are kind of physiological principles that are getting analyzed in that software to either validate them for you as an individual and then predict what a certain training program would end up resulting in. So I think that's what you're going to see down the road, is to be able to say, I'm going to match my aerodynamics, I'm going to match my red blood cell profiles at altitude, I'm going to match what my ability to recover from anaerobic effort is, and I'll be able to do that for me, not necessarily 50 people that are in a study.
No, but it's essentially, it's an increase in individualization.
Yeah, but it's predictive. But I don't think the predictive is there yet. The post analysis is pretty good right now, but I think a lot of people are getting a little bit mixed up, or they're valuing the post analysis as predictive, and they're weighing that too heavily. So I think that's what we're in the midst of our next couple of year change here.
Yeah, I agree with you. I actually just read an interesting study. The title was a little deceptive, saying that it compared a training plan developed by British Cycling to a training plan developed by a computer, and found that the computer's plan produced greater gains. But when you actually dug into the study, they didn't have athletes actually use either training plan. They just simply looked at its effects on the PMC and said the computer-generated training plan produced a higher CTL, so therefore it was better. I found that really interesting. You said, because you can go, well, that's nice, but that doesn't mean that's what's actually going to happen with a real athlete.
Yeah, that's not good. And that's exactly what I'm saying is the problem is a high CTL doesn't necessarily, and that's what we repeat over and over and over, is the best predictor of performance or measure of performance is performance itself. And Andy Coggan always kind of preaches that. And if you've been in the sport long enough, there's so much variability, even if you're looking at artificial intelligence and so on, and how you're going to adapt it, to take so many variables in you have to have an accurate measure. And the software analytics will help you with that. But the prediction of those things is very difficult on those tools. Those tools, CTL, ATL, for an individual vary. And you can ad hoc post-analyze them and get to a close number, but that's good. I mean, we've made a lot of headway. Before, you'd have an error in the power meter, you'd have an error in the measurement, you have an error in the software, you have an error how you smooth the data, and so all that adds up. So if you said at the elite level you had a 5% error, well, that's a big difference between getting the medal and not getting the medal, so it wasn't that accurate. Now I'd say that if you have the right measurements and some of the training that got you the CTL that you best performed under for you, then you'll probably get a result within a 2 or 3% of what you thought you were going to.
Descriptive and predictive analytics are actually just the first of two phases. Let's get back to our conversation with Tim, where he talks about the phase that's still 5 to 10 years away, but maybe the most exciting, prescriptive analytics.
It's really going to get exciting in the next couple of years, even though I think that next couple of years can be 5 to 10 years before we could really see it mature, is prescriptive analytics. So prescriptive analytics reverses predictive, right? That means, hey, I'm an athlete and I want to get this. I need more 10-minute power. I need to be able to sprint better. I need to be able to survive 6 short, punchy climbs on this one crit. How do I do that? And then the software can say, oh, here's the best training for you to accomplish what you want to accomplish. That's when you get predictive. So the predictive analytic is the athlete, the coach, whatever, says, I need to create this for my athlete's success based on the demand of an event, what it's going to take for them to win an event or a race or whatever they're in. And then the computer will come back based on historical performance and having data on that athlete and say, oh, here's what you should do. That's the most effective and efficient way to create that result. That's the future in front of us that I personally believe we're not there yet. There's a lot of variables. There's a lot of things that we don't really control. We don't have enough data collection capability yet to be truly prescriptive, but we're on the cusp. It's getting there. And if it ever gets there, it will be in the next 5 to 10 years.
What sounds exciting about it is, so we talked quickly about the performance management chart. The performance management chart just gives an overall level. It doesn't say anything about, are you a good sprinter? Are you a good time trialer? Things like that. But it sounds like what you're talking about with this prescriptive stage is you can say, I want to win a time trial, or I want to be a stage racer. And it can really hone in on the assets or the physiological changes that you need to have the right assets for the particular target that you have. Is that what you're saying?
Yes. One caveat, though. Mm-hmm. It doesn't mean a sprinter can become a good time trialer. Right. Yeah, exactly. But it does mean if you so made that choice, the system can tell you, here's your training strategy and here's are the best type of workouts you should be doing. And even beyond that, and this is stuff we're doing now, is it can tell you the exact relationship in training between time and intensity. Should I do a 3-minute interval or a 6-minute interval? Well, you can use the system. The WKO4 power duration model kicks off right now, optimized intervals. And that might say do 4 minutes and 48 seconds at 365 watts. Now, I'm using examples that are slightly over precise because there's a slight plus minus around that. But it gives the person, a coach or a self-coaching athlete, a much more clear target. So what prescriptive analytics will do is say, oh, here's your training strategy. Here's the type of workouts that you should do, and then utilize the same data, the same AI, the same machine learning to say, oh, and by the way, it's not 3 minutes for that interval or 5 minutes for that other one. You should be doing them at 4 minutes and 15 seconds. And then you should be plus or minus 350 watts plus or minus 10. Right. So it's actually going to even change the way we think about zone and targeting training.
It's a prescription. It's like you go to the doctor, you tell them what you want to do, and the doctor in this case is the program that interprets all the data and spits back out a prescription that says, do this, do this, do this, in a sense.
Correct. Because what you're doing now, imagine the same example, right? You get sick and you're self-treating and you don't have a lot of data. So you do 10 different things to get healthier. You take vitamin C, you sleep more, you drink more water. who knows, you wrap garlic around your throat, whatever thing it might be, right? And then if you get better, you say, great, I got better. It must have worked, but you don't know what worked. And then in the future, you don't know how to replicate it. So if you said, I got sick again, you do the same 10 things, right? Thinking that was the mix. Well, the reality is the prescription might be it only takes 1 or 2 of the things you did. Mm-hmm. And if you could hone in on that prescription, then you have more time, more ability. You can just get at the things that matter because the prescription is going to say, here's what matters. Here's what's effective in creating what you need.
Right. So that would allow riders to scrap workouts that wouldn't result in improvements and target more workouts that would do just what they're looking for.
I bet you that will be the number one advantage when it really all comes to bear. It's not so much, look, there's a lot of smart coaches and smart athletes in the world, and they've learned over time, like, wow, if I do this, I'm doing that. And they know how to get on form. They know how to train in the basics, and they know how to get on peak. But what the data will tell them in the first wave, and you can do it now, is you can find out the non-productive things. If you think about improvement and creating, cycles of improvement, eliminating non-productive behavior is the first step. And that is a big deal to training because if you could replace non-effective training time with effective training time, generally you get faster and stronger. It's what happens.
I bet there are a lot of listeners out there that are salivating just listening to this conversation and what it will do for their training, their fitness, their performances. On the flip side, there's probably some coaches out there thinking, do I have a job in the future if this technology comes to full fruition and it's able to prescribe these workouts without a coach's interpretation? So I'm wondering if we could jump into the value for both athletes and coaches of this next phase.
I think that's a great question, right? And for the, I've done a lot of webinars and training and education programs. People know that I have an honesty, a blunt honesty issue, I guess. So let me answer it that way. Let's start with coaches. I think this is going to be one of the most dynamic tools in improving the good coach performance. Now, I'm choosing my words carefully here because I think coaches that invest in this learning, right, are going to benefit. And here's why. So think about the athlete, what I said before. You have this modern athlete, right? And they've got 2 wearables on. They got heart rate monitor. They got a power meter. They got a speed sensor. They have an accelerometer in their bike. They're motioning how much they're measuring how much they're rocking the bike and where their pedal stroke is and all of this data, right? So if you're a coach and you have, let's say, 10, 20 athletes in your system, remember that athlete, that individual athlete goes home, they plug in their data recording device, and they sit down at their cockpit of computer screens, which now looks like a jet fighter, right? And they're looking at all of that data. They're looking at it every day now. And if coaches don't get better at compiling and utilizing that data, that's what things like AI are there for. That's what these software programs are out there to do the analytics. So you're not doing all the legwork, to boil it down into cause and effect, dose and response. Is this working? Is my athlete improving? And can I communicate that improvement to them? You're going to struggle because the athlete's going to sit at their cockpit every day. They're going to go out and ride with all of those devices. They're going to plug in that data recording device, and they're going to look at all of that data. And you as the coach have to boil it down to something. That's where investing in learning and understanding what is now all of these different types of analytics, I would call advanced analytics, good coaches are going to thrive because, yes, you have a learning curve, but man, is it going to teach you a lot. It's going to give you insights. It's going to help guide the decision-making process. It's actually going to make your job easier once through the learning curve. The downside of that is if they're not just a good coach, I don't want to say bad coaches because it sounds sophomoric, but if there's people out there, coaches out there that are taking on clients and they're not investing in their own education and they're not learning about the underlying physiology, the underlying methodologies, and they're just kind of throwing workouts out there and hoping to get paid, they're going to fail more because your point is exactly right. The athlete themselves, eventually their cockpit's going to evolve and they're looking at the same data. And they're going to say, well, wait a minute, my coach is prescribing this, and this, and that doesn't make sense. And I can see at a physiological level, my VO2 max is going down. I don't care what my coach might be saying. My modeled FTP or FRC, those are going down. What's going on here? So the coach is going to get a couple more questions. Good coaches thrive under this type because they learn how to use a superior tool in a superior fashion. Right. Bad coaches that don't invest themselves get exposed. It's going to happen.
Yeah, we were talking about this earlier, and it seems like the coach who should be a little bit afraid is the one who just likes to pump out kind of generic 6-week training blocks and hand them to the athlete and say, just go do the training. Because that, to a degree, can be automated. And as you said, the athletes can now really see the effects of their training. So the good coaches are the ones who are actually going to be using these tools to really see what's happening with their athlete and adjust the training accordingly. Is that what I'm hearing from you?
I think that's exactly right. The bad coach gets replaced by a training plan. It really is that simple. The good coach, the only add I would add is the good coaches are going to see better and better results with their athletes. The machines will quickly replace the bad coaches, and that's going to be training plans or dynamic training plans, but that's also coming down the pipe.
My personal opinion is I always say that the training plan is 10% of coaching. That's the easy part. The hard part is the sleuthing and the individual interaction and helping an athlete when they get sick or work is hitting them hard or they have a lot of travel. It's all the things that unfortunately you can't automate.
I agree. I couldn't agree more. It's so funny. I'm a data preacher, as people know. You know, it's funny. It's like Andy and I talk about this all the time. It's the science and an art. And you can't, the both working together are the ultimate solution. If somebody thinks it can be turned all the way into science, I personally believe for everything I'm talking about, machine learning and AI, I don't think it will ever truly get there. There's too many human variables. I think some people might be threatened by your point, but I don't think we'll truly get there. I think if the art of coaching is being enhanced, the art is being given better tools to perform with, and you're getting better and easier access to the science. So just utilize those and become a better coach.
Let's check back with Armando and his thoughts on this ever-growing dashboard of data that both coaches and athletes have at their disposal.
I believe that the software is going to start to incorporate a broader range of information. So as we instrument more of our lives, right, that this information is now going to be incorporated as part of our overall training. So one of the biggest challenges with our software, and I think for a lot of software, to be able to really prescribe training is that there's just so many variables involved. So you're only really looking at it through one lens, right? So if all you have is power data, and you only have power data for indoor rides and not outdoor rides, or we only have power on one bike and not on the other bike, it's really difficult to get a real clear picture of what this athlete's, what kind of training they've been doing. And now when you start to incorporate other types of training, whether they're in the gym, they may have other types of sports that they want to train as well. Maybe they're a triathlete doing multiple sports, in which case you need the instrumentation across these other sports as well. I think that's where really the tension is going to be, is how do you provide a greater holistic view of training beyond just cycling? I think cycling is great because you really created a way to kind of quantify things that you're unable to quantify in other sports because of the availability of the power meter. But we can apply the same principles across other sports and start to quantify and use these same ideas for different types of activities.
Do you also see that incorporating recovery metrics, so sleep?
Absolutely.
You have this new, obviously people, you can think of the Fitbits, which track, how active you are through the day.
Absolutely.
So do you see those sorts of things being incorporated into the software?
Absolutely. So, when I would talk about the instrumentation, this is what we're talking about is, are we going to be able to collect sleep data? Are we going to be able to collect HRV data? Are we going to be able to collect other data related to how our various muscles are performing or being used, like, maybe motion? There's a whole bunch of information that we can collect. And with the availability of this other information and the ability with the computing power that we have now available to us, we can start to use that information to better identify what is best suited for a particular individual, given the types of exercise that they're performing, the information that you're gathering, and then the types of athletes they want to become. All that information is now going to be much more valuable and useful, rather than getting a very narrow view of an athlete, that now you're getting a greater 360 view of that athlete.
Now, what do you see the software doing? Because that's going to be a ton of data. Obviously, they're not going to want to be sitting there trying to analyze all that data themselves or interpret it. So what do you see happening with the software in terms of using that data? What's the software going to do with it?
Well, there's, when it comes to things like machine learning and neural networks and capacity of the software to use this computing power, certainly there's a lot of opportunity. We do have a lot of data. But the challenge with a lot of the machine learning processes is that how do we identify what we're trying to optimize? That's the biggest challenge, right? So I was reading this paper recently by Tanya Churchill, who's based out of the University of Canberra. So part of her PhD thesis she did is sort of machine learning for training, implemented what's called an hybrid artificial neural network to analyze all this training data for cyclists, right? Which is really good. And if you're ever interested in understanding kind of how machine learning will be able to be applied, what the challenges are, she really gets into a lot of great detail. So I'd recommend anybody who's interested in this to read her report. There are a couple of really big challenges, right? The big challenges is what are you trying to maximize? What's the goal? What's the objective, right? These are really difficult to identify. So that's one of the challenges, is to identify within the data itself what are the goals of the particular training, and those can be a challenge. And then the other challenge is that the data is very individualistic. Everyone comes into training with some level, some context, and you as a coach would know that when you first have an athlete, you need to understand you have to learn the athlete first before you can really tell them what to do, right?
Right.
So part of this whole process is gathering data first about an individual. So all this data needs to be collected first before we can start to use it and make meaningful information out of it. So if you're just going to show up and you have all these new devices attached to you and you say, okay, I'm going to get the best training, well, you're not there yet, right? You're going to have to collect the data for a period of time before we can really prescribe the training. So everything is very individual. So you can't really solve that problem by throwing more data at it, because each individual is different, and where they're starting the process is very different.
Now that we've talked about the impact on coaches, let's ask Tim what the benefits are of the software to athletes.
Bias and bias control. So much of my coach learning has come from failure. Meaning so many times you've just been like, man, I'm working so hard with this athlete. I want to get everything right. We're doing this training and I'm going to implement this new idea and I'm working on that, right? And the athlete doesn't achieve their goal and it's heartbreaking. And you're like, oh, that's so hard for me. And you fail and you fail and you fail. And then eventually you start learning from all that and you get smarter and better and smarter. Now at a personal level, right? You think you could take all that learning and all that mistakes and the success you've had with your athletes and apply it? It's really hard because we're more biased when we coach ourselves than we even can admit. And the reality is we introduce bias in our planning, in our diagnosis, meaning, what we look at ourselves as an athlete and say, what do we really need to be successful? In our prescription, like what amount of work am I really going to do and have the time for? We introduce a lot of bias in self-coaching. Where machine learning and AI and these type of insights will do, you should look at each phase of your self-coaching relationship with yourself, I guess, and remove the bias. It's not about what you think, like, I think I'm a better sprinter than I am, or I think I'm I have better longer power than I really have. And you use the modeling and the data and the things that are coming out, to remove that bias as best you can. And that's not just diagnostically, but it's workout to workout. Did I really do the work? Could I have gone harder? Was I going too hard? This type of analytics that we're seeing, in WKO4 and by utilization of power duration curves, which give clear ideas of what I could have been able to do, it makes me be more honest about, should I have failed? Why did I fail? Did I have the right prescription? So it does remove all of that bias from the individual coaching athlete and makes them better in that way. And then two, it gives guiding insight. You do get those same insights where, man, I could do an interval at, I should be doing 4 minutes and 15-second intervals at 350 watts. That's there also. But what you lose is the athlete is what happens if you fail halfway through that. Do you have a coach who's well experienced and can talk to and work through? So it does help the athlete that way. It does remove bias. It does give direction and insight, but it doesn't become the wisdom and exchange that you would have with your coaching. You never recapture that art.
As we've already pointed out, amateur racers seem to be adopting the data revolution quicker than the pros. I caught up with Joe Dombrowski of the Education First DrePack World Tour team to get his thoughts on the latest software and why pros have been slower to adopt them.
Yeah, I actually was working with a guy last year on a machine learning software that was predictive in terms of basically how long a rider could sustain whatever effort they were at in real time based on data accumulated over hours and hours of riding of, heart rate and power.
Mm-hmm.
It seems like one of those things that's popping up more and more now. Even like I've noticed, I use the Garmin 1030 in training, the new one.
Yep.
And when you finish your ride and you click save ride, it has all these metrics that pops up, like your new VO2 max, or your, this was how much anaerobic stress you had in this ride. This is how much recovery you need. From what I gather, it seems like it learns you over rides and races, and basically using your data to sort of model or try to model with suggestions for maybe how long you need to recover, or how hard your ride was, that sort of thing.
Is that something that you use at all, or do you sort of see it as it's in its infancy, maybe someday I'll use when it gets a lot better?
I would not say it's something I use. It's interesting. I could see it being something that potentially is useful in the future. I think at this point in time, there's so many inputs when it comes to training and racing, and machine learning as it applies to data for us cyclists. In my experience, it seems like most of it is power and heart rate dependent. And I don't know if there's much else that goes into that. To get an accurate read on a lot of that stuff, it seems like the picture would need to be a bit more holistic. Like even something like, how are you fueling? Are you trying to lose weight? Are you restricting carbohydrates? I guess to me, and this may change, but at this point in time, it sort of seems like, well, if it doesn't know that, how can it accurately – do you know what I'm saying?
Yeah, exactly. It doesn't have all the information to make judgments necessarily.
Right. So, yeah, I guess I've seen more of that. It's interesting, and it'll be interesting to see where it goes. But, do I make use of it? No, not really. And I would say in general with that sort of thing, I would say most World Tour riders are not super keen on that. I guess I would say most riders are happy to have a coach basically tell them what to do, and they go out, they train hard, they rest hard, they focus on the basics, and really they have killer instinct. And that's what makes them great riders is, they're highly motivated and work really hard. I guess from my point of view, like the tech side of it is interesting, but and maybe I'll eat my words in 10 years, but like at this point, I don't really see it offering that much to me. It's sort of like last year when I was working a bit on this this machine learning project in terms of like sort of predictive, how long you can sustain this given pace. It was interesting, but I think it would probably be most applicable to amateur riders, because I would say in general, professionals have such a good feeling for kind of where they are in an effort. It's almost akin to like, for example, I've been riding this new saddle, and you have to adjust the saddle height at the seat post a bit because maybe like the stack height of the saddle is slightly different to get it to the same position. This was the case this year. Well, I changed saddles this year, and just going by feel, not really measuring it at all. Like I'll ride, 30 minutes and then put it where it feels right. And then when the mechanic came to take my measurements with the new saddle on, and I was like, okay, I'm happy with this now. It was on the exact same millimeter in terms of saddle height and setback of the old saddle. So I guess that's kind of an example of where, like, when you do that much riding, I think you have a really good feel for like where you're at. I suppose in my mind, some of this machine learning technology as it's coming along, it could be potentially quite useful to really most of the general public who, don't spend all their working hours on a bicycle.
Right.
Now, you also said in your notes, one of the benefits to the athlete is individualization, which is one of the aspects I love. You were talking about the power duration curve. Everybody has a different shaped curve, and looking at the shape of your curve can tell you a lot about both the type of rider you are, but also your strengths and weaknesses and what you should potentially be working on.
Yeah, great catch. So really, when you think about what's been the biggest improvement of the revolution, right, where we're standing here today, my answer would be the individualization of training. That's the umbrella that all of this improved results is living under. So 10 years ago, you had a system that was based off a number, FTP, and then you would work in training zones and levels, actually is what they were originally. And you would target these levels, and we would assume that everybody generally fit within the bell curve of the way the levels were written. Where today, we don't really think like that anymore. The reality is we're utilizing the performing data to define the individual athlete's physiology. Once we understand your physiology down to muscle fiber type and VO2 max and metrics like P max and your FRC and FTP and stamina and time to exhaustion, we could do all that we know your underlying physiology. So if we know the underlying physiology, the prescriptions of workouts, of training strategies begin to train. So for example, let's say I ride with a local guy here who's a really good time trialist, and I'm more of a pursuit sprinter style rider. I'm punchy and sprinty, and I don't like to ride my bike for more than 20 minutes hard ever. Not just ride my bike more. So the reality is where this person's really good at time trial. We have the same threshold, but we train using eye levels and optimized intervals, and we train together, 1 to 2 days a week. So when we train, we're doing intervals together. If we're doing longer intervals, he's usually he needs to go a little longer than me, i.e. your point about optimize, and he's typically going a little bit harder. If we're out there doing short intervals, I might be doing 100 watts more. And that my target is 100 watts more. In the old system based off levels, FTP and levels, a lot of coaches would have prescribed both those athletes at the same for that 2-minute interval, where once we understand the underlying physiology and the program is giving you some insights into the best response that you're looking for, you can say, wow, athlete A needs to be doing that at 500 watts and athlete B needs to be doing that at 400 watts and tweak the times. That individualization, whether you're a coach or an athlete, you get the advantage of that. That's one of the key changes and one of the key reasons why we modeled physiology, not predicted power, so we can really target the individual.
Right. And this goes back to that whole point that the FTP does not give a complete picture of an athlete. And I think so Chris and I just did that climbing article with Sepp Kuss, and you look at me, I'm a time trial style rider, so my VO2 max power is very close to my threshold power, where somebody like Sepp, who's a climber, we measured his threshold at about 326, but he was able to go out and do a 23-minute time trial at 387. So very, very different type of rider, and you just can't capture that in the threshold in the FTP.
Absolutely. And, and you see it in coaching all the time. I know you run into it, and now you can quantify it too. That was such a great article you guys did. And I really hope people read it like 5 times because not just to help you guys with some magazines, but the reality is, you read an article and you read all the words, right? You put all those, it's like looking at all the trees in the forest. But I hope people step back and look at the forest. Every rider right now listening to this podcast could go out and learn that same stuff about themselves. And they could learn it and apply it and become a better climber and find ways to maximize it. You had some great insights into how you were each climbing in there. I thought it was awesome. You could look at that same analytic. That was great how you guys did the kind of heat map approach. That was awesome. That's available to anyone right now. You could totally learn all that in an individual basis just by data. You don't need to go to a lab. You don't need to invest in, big programs and stuff like that. The power meter, the data devices that you're collecting data with can give you access to all of that. All you need is some software and some learning to unlock it.
So I'm going to say I hope everybody reads it 5 times as well. Again, not because I'm trying to sell magazines, because it really hurt.
Great stuff, you guys. That was an awesome article.
Thank you.
Thank you for saying that.
So, Tim, to wrap up all of the fascinating stuff that we've talked about today, maybe you could bring it back and give us and the listeners out there some simple take-homes from all of this information.
I think the simple take-home, it might surprise you, is I think people should be encouraged by listening to this type of discussion to go out, see what's out there, and learn and find out, how to begin to utilize this data. Meaning everybody listening knows there's more data than ever, right? Because you're wearing the devices, you're collecting the data, you're plugging into the cockpit. Where I think it really is such a fun time in our sport, it's an interesting time in our sport. My number one take home is it's a great way to improve your training, whether as a coach working with athletes or a self-coached athlete or just somebody who wants to learn. It'd be easy to say, do it this way, and here's my opinion, and here your take home should be train harder. My take home is smart coaches, smart athletes, people who invest in their own learning always end up with better results. You have all this great data and you have all this great analytic tools, of which our software is not the only one. TrainingPeaks WKO4 is the product that I represent. It's in my title, so I can't duck it. But on the same side, I try other stuff. I'm always looking at other things. I really encourage people to go out there right now and look, learn. And I know it's a little bit of learning curve. Push through the learning curve of what's happening with data, and you might find those significant improvements in training that you've been looking for. I think it will surprise you if you put in the time and go out and experiment with some of them.
That's great. So my take home, I just have one, but you touched on this at the beginning of the podcast, and it's such an important point to me. And I say to my athletes all the time, you always have to be willing to face yourself. So to explain that, this is called a training tool, not a racing tool. So it's not about peak numbers, peak performance. Racing is about peak performance. Training is about training right, meaning doing your intervals at the right intensity, doing the right length of interval, doing the right accumulated volume of interval. And if you are trying to fool yourself and look for peak numbers, you aren't going to train right. So go into, when you're using these tools, go in with an open mind and just say, what is this tool telling me about myself? Instead of going into it saying, here's what I think about myself, and I'm going to fudge this data until I get it to tell me what I want to see. Just let the tool tell you where you're at, look at its recommendations for how to train, and then go and try to use that to train right.
I think that was a great answer. I should have stole that.
Sorry.
No, it really, don't try to self-validate, learn. I think that's a great point.
Hey, Tim, one other question for you. What does WKO stand for?
That's super secret. If I told you, we'd have to kill you. So WKO stands for workout. So don't overthink it. We just needed a name. This goes back to Kevin and Gear and Hunter and the gang way back in the day. They just needed, like every file has an extension. And they were like, what extension should we use? And they said workout. And we said, okay, WKO.
There you go. That was another episode of Fast Talk. As always, we love your feedback. Email us at webletters@competitorgroup.com. Subscribe to Fast Talk on iTunes, Stitcher, SoundCloud, and Google Play. Be sure to leave us a rating and a comment. While you're there, check out our sister podcast, the Velo News podcast, which covers news about the week in cycling. Become a fan of Fast Talk on Facebook at facebook.com/VeloNews and on Twitter at twitter.com/VeloNews. Fast Talk is a joint production between Velo News and Connor Coaching. The thoughts and opinions expressed on Fast Talk are those of the individual. For Trevor Connor, Tim Cusick, Armando Mastracci, Dean Golich, and Joe Dombrowski, I'm Chris Case. Thanks for listening.